Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in as we go through factorisation, which is actually the opposite of expansion. So hopefully you know that if you have something like x plus 2 times x plus 3, you can expand that using FOIL and you get x squared plus 5x plus 6. So we've done expanding, which is when you start with things in the brackets and you go this way. So you start with brackets and you end up with something that doesn't have brackets. Today we're doing the opposite. We're starting with an expression like this and we're going to write it as something times something. So that's what factorizing means, putting it into factors. So we start with something without brackets, we end up with something that does have brackets. So it turns out, just to be complicated, the way that you do this differs depending on whether you have a binomial, 2 terms, or a trinomial, which is 3 terms. So let's start by looking at binomials, things with 2 terms. So what you do first is see if there is a highest common factor. So binomial means 2 terms. You first see if the 2 terms have a common factor. The other method we might use is dots difference of 2 squares, which we looked at in the expansion video. So you might end up using both of these, but always start by trying highest common factor. So let's have a look at some examples. So let's start off with the example 5x plus 10. Okay, so we've got an expression that doesn't have brackets. We want to write it as something times something. So we first try highest common factor. Do the 2 terms have a highest common factor? So this is one term and this is another one. So 5 and 10 have a highest common factor of 5. So we write down the common factor. Now what goes in the brackets? The first term divided by the highest common factor. So 5x divided by 5. And then the next term positive 10 divided by 5. Okay, so now if I were to expand this using the distributive law, I would get back what I started with. So expanding and factorizing undo each other in exactly the same way as multiplication and division or addition and subtraction. Okay, let's look at another example. Again, we're looking at binomials. So let's look at something like 12x plus 15. So first term is 12x, second term positive 15. Do they have a common factor? Well, if you're looking for a common factor, note that the highest common factor of 2 numbers is always a factor of the difference between the two. So 12 and 15, the difference is 3. So their highest common factor has to be a factor of 3. So our only choices are 3 and 1. So 3 goes into 12 and 15. So I write that out the front. I take my first term, 12x, and divide it by 3. I take my second term, 15, and divide it by 3. Okay? If I had something like 15x plus 24, the difference between 15 and 24 is 9. So again, the highest common factor has to be a factor of the difference. It has to be a factor of 9. So 9 doesn't go into either, but again, 3 does. So I write 3 out the front. I take my first term and divide by 3, so 15x divided by 3 is 5x. Take my second term, 24, and divide by 3, and I get 8. Now what I want you to notice is that when we're using highest common factor, the highest common factor is not always a number. Sometimes it is, sometimes it's a letter, sometimes it's both. So if we have something like x squared minus 6x, there isn't a common factor other than 1 that goes into x squared and minus 6x. The only number that goes into 1 and 6 is 1. So we have to look at letters. Now both of these terms have an x, so that is a common factor. So this time I write x out the front. So take my first term, x squared, divide by the common factor, I just get x. Take the second term, which is not 6x, but negative 6x, divide by x, and you get negative 6. So again, if I expand this using the distributive law, I get back what I started with. Let's say I have something like 12a squared plus 20a. So this time, there's a common factor of a letter, A, but 12 and 20 also have a common factor. Again, the difference between them is 8, so the highest common factor has to be a factor of 8. So it's not 8, it's 4. So 4a is the highest common factor. So I go 12a squared divided by 4a. 12 divided by 4 is 3. A squared divided by a is a. 20a divided by 4a just equals positive 5. Again, if I expand this, I will get back what I started with. So all of these have involved a highest common factor. Let's look at ones that don't involve a highest common factor, but involve difference of two squares. So quickly, remember if we were expanding something like x minus 5 times x plus 5. Remember there was a quick way to expand this. Because the middle term cancels out and I have the same terms in each brackets, just one with a minus, one with a plus. Remember what I did was just square the first, square the second, and stick a minus sign in between them. So we can use that fact to factorize the difference of two squares. So if I have something like x squared minus 36, and I want to factorize it, so there's no common factor between the two terms, but I can use this process just in reverse. So I know it's going to have two brackets, and it's going to be x in both brackets, because the square root of x squared is x. The square root of 36 is 6, so I put a 6 in both brackets, and one has a plus, one has a minus. If I expand this, I'll get that. If I have something like x squared minus 64, so I put x in both brackets, square root of 64 is 8, so that goes in both brackets. One is a plus, one is a minus. It doesn't matter which one's the plus and which one's a minus. Let's say I have 4x squared minus 49. So again, there's no common factor between the two terms 4x squared and negative 49, but this is the difference of two squares. So what I do is I square root the first thing. So square root of 4 is 2, square root of x squared is x. That goes in each bracket. Square root of 49 is 7, so I put that in each bracket. One is a minus, one is a plus. Now sometimes you'll have to use difference of two squares and a highest common factor. So let's say I have something like 8x squared minus 98. So here, 8 and 98 are not squares. They're not perfect squares. So I can't just use the difference of two squares. But 8 and 98 do have a common factor. And their highest common factor happens to be 2. So what I can do is take out a factor of 2. So 8x squared divided by 2 is 4x squared. Minus 98 divided by 2 is minus 49. So now you can see that this is exactly the same as the expression we had in the previous example. So I can factorize this further into 2x minus 7, 2x plus 7. Okay, so always try and use highest common factor first. Okay, I'll give you one more example. So let's say I have 32x squared minus, let's say, 50. Okay, so again, can't use difference of two squares straight up because 32 is not a perfect square, but the 32 and negative 50 have a highest common factor of 2. So I take that out. And then I use the difference of two squares on this part here. So the square root of 16x squared is just 4x. Square root of 25 is 5. So both brackets have a 4x and a 5. Just make one a minus, one a plus. How easy is that? So unfortunately, I now have to show you how to do trinomials. So we do factorization differently when there are 3 terms. So please pause and copy down if you need this. So to factorize trinomials where there are 3 terms, we need to find 2 numbers that multiply to the constant term but add to the coefficient of x. So let's look at an example so this becomes clear. So let's say I want to factorize x squared plus 6x plus 8. It may look like it, but I can't actually use highest common factor here because even though x squared and 6x have a common factor, even though 6x and 8 have a common factor, there is no common factor for all three terms. There's nothing that goes into all of the three terms, and that's why I need a different method. So note that this is the constant term because it has no x's attached to it. So the constant term is positive 8. The coefficient, i.e. number in front of x, is 6. So I need to find two numbers that multiply to 8 and add to 6. So go through factors of 8. So I have 8 and 1. Well, they don't add to 6. 4 and 2. They do add to 6. So what you do, your answer is always going to have two brackets, x's in each, and you write those two numbers that multiply to the constant term and add to the coefficient of x. So they were positive 4 and positive 2. We're actually done. Now, if I expand this using FOIL, I will get that. Let's look at another example. So let's say I have x squared plus 7x plus 12. So I need to find two numbers that multiply to 12 and add to 7. So think factors of 12. 12 and 1 doesn't work. 6 and 2 doesn't work. 4 and 3, oh, they do add to 7. So it's going to be x plus 4, x plus 3, because 4 and 3 multiply to 12 and add to 7. Note it doesn't matter if you write x plus 3 times x plus 4, because we're timesing here. Order in which we multiply doesn't matter. So these get harder because sometimes they'll involve negative numbers. So let's have something like x squared minus x minus 6. So here I have to find two numbers that not that multiply to 6 but multiply to negative 6 and add to negative 1. So let's go through factors of 6. Okay, so 6 and 1 wouldn't work in any combination. What about 3 and 2? Well, if you had a negative 3 and a positive 2, they would add to negative 1, which is the coefficient of x, and negative 3 times positive 2 equals negative 6. So we're done. That's our answer. One more example. Let's say we have something like x squared minus 9x plus 20. So here we've got two numbers that multiply to give positive 20 but add to negative 9. So both those numbers here must be negative because two negatives multiply to give a positive and they add to give a negative. So it'll be x's in both boxes, okay? So I've just got to look at factors of 20. So 10 and 2, well, that wouldn't work. I couldn't use negative 10 and negative 2. What about negative 5 and negative 4? Well, they do add to negative 9. So I put them in there. It's as easy as that. So that's how you factorize quadratic trinomials. All right, I hope this video hasn't been too long for you. This has been the luckiest maths teacher in the world. Have a great day.